Hello friends, welcome to EC Academy.
In this lecture, let us understand the time response of first order control system. Figure shows the block diagram of first order control system. We can write the overall transfer function as C of s divided by R of s is equal to 1 by Ts divided by 1 plus 1 by Ts into 1. From the block diagram, we can identify G of s is equal to 1 by Ts, H of s is equal to 1. That's why we have written it as G of s divided by 1 plus G of s into H of s. So H of s is taken as 1. If we simplify this, we can write this as 1 divided by Ts plus 1. Therefore, the overall transfer function C of s divided by R of s, we can write it as 1 divided by St plus 1. Here T represents time constant of the system. If we observe the highest power in the denominator, it is 1. This identifies the order of the system. The order of the system is 1. That's why we can say the given system is first order system. From this equation, we can write C of s is equal to R of s into 1 divided by St plus 1. Since R of t is equal to 1, therefore Laplace transform of R of t can be written as R of s. So it is nothing but 1 by s. So R of s is the Laplace transform of R of t, which is 1 by s. So we will substitute this value here. So it will be C of s is equal to 1 by s into 1 by St plus 1. Now let us use partial fraction. So we can write C of s is equal to 1 by s into 1 by St plus 1 will be equal to a divided by s plus b divided by St plus 1. Let us take this as equation number 1. From this equation we can find a, that will be equal to limit of s tends to 0 s into C of s. So C of s is equal to a divided by s. So we can write a is equal to s into C of s. So we can write this as limit of s tends to 0 s into C of s is 1 by s into 1 by St plus 1. We can substitute that value 1 by s into 1 by St plus 1. So from this equation we can cancel out these two s. If we apply limit s is equal to 0, this term will become 0. So from this equation we can write a is equal to 1. We can find b. B is equal to limit of s tends to minus 1 by t. So from this denominator we can find this limit. So we can find s is equal to minus 1 by t. To find b, we will apply limit s tends to minus 1 by t. So we can multiply St plus 1 into C of s, St plus 1 into C of s. So we can write this as limit of s tends to minus 1 by t, St plus 1 into C of s is 1 by s into 1 by St plus 1. So we can cancel out these two terms. If we put limit s is equal to minus 1 by t, so the value of b will be equal to minus t. So we found both the values of a and b. We can substitute those values in this equation. Equation 1 will be equal to C of s is equal to 1 by s, because a is equal to 1, minus t divided by St plus 1. So here b is minus t. We have substituted that value in this equation. Now we can write this equation as C of s is equal to 1 by s minus 1 divided by s plus 1 by t. Now let us apply inverse Laplace transform. So we can write C of t is equal to if you apply inverse Laplace transform for 1 by s, it will be 1 minus this term will become e to the power of minus t by capital T. Let us take this as equation number 2. So this equation is true for t value greater than or equal to 0. Now in this equation, let us put at t is equal to capital T. So if you put t is equal to capital T, C of capital T, because we are substituting t with capital T, will be equal to 1 minus exponential to the power of minus t by t. So it will be equal to 1 minus exponential to the power of minus 1. So we can write C of t is equal to 0.63. At t is equal to 2t, C of 2t will be equal to 0.86. At t is equal to 3t, 4t and 5t, then C of 3t will be equal to 0.95 to C of 5t will be equal to 0.99. So when t is 2t, we will get C of 2t as 0.86, and when t varies from 3t and above, the value of C of t will vary from 0.95 to 0.99. Now let us draw the response of the system. This is the response of the system. From this response we can identify that when t is equal to capital T, the exponential curve reaches 63% of the final value. So let us say the final value is 1. At t is equal to 2t, it reaches 86% of the desired value. When t is equal to 3t, 4t and 5t and above, the desired value reaches from 95% to 99%. If t is equal to infinity, if we substitute t is equal to infinity in this equation, then we will get C of t is equal to 1. So this is the desired value. So we can say the steady state is reached only when we make time as infinity. So which means at infinite time the steady state will be reached. So for the first order system we can say the steady state is reached only after infinite time. This is about the time response of the first order system. Hope you have understood the topic. Thank you.